Okay, so today we are going to find the area of regular polygons. A couple vocabulary terms that are important is, first of all, you need to know like how many sides a hexagon has. So a hexagon has 6 sides. Pentagon has 5. Octagon has 8. Decagon has 10. Those are the most common ones. Anything past 13 or 13 on up, we usually just call it a 13gon or a 14gon. When you're finding the area of regular polygons, what you are doing is you are envisioning that, start with an octagon, for example. So if you sketch out, I'll do the best octagon I probably can try to do. There we go. It's not very good, but it'll work. Okay, what you are doing is you are envisioning that this octagon is inscribed in a circle. So what that means is that all the vertices of the octagon are on the circle. Okay? So by doing that, we have a center of the circle, obviously. So that would make from here to the circle, that would make that a radius. It'd also make this a radius and this a radius. Okay, and we know that all radii are congruent. But then we have an introduction of a new piece. And that new piece is called the apothem. Some teachers say apothem, I say apothem. It is from the center and is perpendicular to the side. Okay, so we have an apothem, and it is a segment from the center of the circle and is perpendicular to the side of the polygon. Okay. Some other things that you need to be aware of is that we are going to be looking for this angle measure. That one right in there. See if I can zoom in a little bit. Okay, so we are looking for this angle measure. Okay, so I am going to kind of put this in perspective. If you are looking for the entire thing, that is 360 degrees, correct? But if we have an octagon, and if we envision that each radii, or each radius, okay, so that divides this into 1, 2, 3, 4, 5, 6, 7, 8 little pieces. So 8 little pieces would give me this whole thing. I am looking for half of that. I want to know what this angle is. So you're going to do 360 divided by 2n, n being the number of sides. Okay, so I'm going to do 360 divided by 2 times 8. So 360 divided by 16. If I remember right, this is not a pretty one. 360 divided by 16 gives me 22 and a half. So 22 and a half degrees. So what I'm going to do is I'm going to draw yet again another octagon so you can see exactly where we're at. So there's the center. I'm going to zoom in here. So there's the center of my circle. This is my radius. This is my apothem, which is perpendicular, and I just found this angle to be 22.5 degrees. And then of course, we have a side of the polygon. So what we're doing is we are going to blow up or focus on that triangle that we just created right there. So we're going to be focusing on the apothem, the radius. This is half a side. I'm going to call it M just so we're not confusing it with S, which is a whole side. And this is 22.5 degrees. So yes, we are going to have to be using trig. Okay? So let's start off with an actual problem. So it's going back to the octagon. So if I give you an octagon and I tell you that the side, so we have an octagon, a regular octagon. Zoom out a little bit. We have an octagon, regular octagon, with a side length of, let's say, 10 meters. Okay? So that means that every side is 10 meters. So all the sides are going to be congruent, which means that this much of it is going to be 5 meters. From what we found previously, this would still be the 22.5 degrees. In order to find the area of a regular polygon, the formula is the area of a regular polygon equals 1/2 AP. Sometimes you'll see the P capitalized, sometimes you'll see it 1/2 PA, sometimes you'll see it 1/2 AP. It's the same thing. A stands for the apothem, and then the P stands for the perimeter. Okay, so we have we have the apothem. So I'm going to, just for ease of explanation, we have the apothem, which is A. We know that this is 5M. This is the radius that we don't know, and this is 22.5. Do I need the radius? 1/2 apothem perimeter. No, I don't even have to have the radius. So 1/2 apothem I have to find yet, but the perimeter is going to be, let's go back up to here, each side is 10, and I have 8 sides, so 10 times 8. So to find the apothem, we're going to have to use trig. Tangent of my angle of 22.5 should equal my opposite over my adjacent. So I have 5 divided by the tangent of 22.5, and that gives me an apothem that's approximately equal to 12.07. That is how I'm going to find the area of my regular octagon. So 0.5 times 12.07 times my 10 times my 8. I could have just put an 80. So I have 482.8 meters squared, because we're still talking about area. Okay? So let's do another one of those. A lot of times I don't even draw the whole diagram. So if I'm trying to find the area of a regular pentagon with, we'll do with a radius of 6 centimeters. Okay, so most often I will just focus on that triangle, knowing that this is my radius, this is my apothem, and this is half of my side. So you need to remember that that's half of your side. Okay, radius of 6. I know that this is going to equal 6. I know the formula is 1/2 apothem times the perimeter. So I got to find this angle. So I'm going to do 360 divided by, a pentagon has 5 sides, so I have to double that, which means 10. So I know that my central angle here is going to be 36 degrees. I need to find this piece and this piece. So I'm going to have to use, need my apothem, so I'm going to find my cosine of 36 equals my apothem over my radius of 6. So using my calculator, I have 6 cosine of 36. Means my apothem is about 4.85. And then to find my half of side, I'm going to use my 6. So I'm going to use my sine. So the sine of 36 equals my half a side over my hypotenuse. So 6 sine of 36. So I get my m to be about 3.53. So I know that my apothem is 4.85. My m is approximately 3.53. I need to take that times 2 to get my entire side. So my side is 7.05. So 1/2. My apothem is 4.85 times my perimeter, which is my side, times the number of sides, which is 5, because we're dealing with pentagon. So typing that in, I have 0.5 times 4.85 times 7.05 times A5. And I get an area of about 85.48. And I think we were dealing with centimeters squared. Okay, now just keep in mind that we are doing a lot of rounding. We rounded here, we rounded here. I would definitely take these out to at least the hundredths, if not more. Just keep in mind that it's going to make this off ever so slightly. So you might end up with a neighbor that does a problem but has like 86 point something, or someone that has like even 84.9 something. So there is going to be a little bit of give on the rounding. Okay, but that is how you find the area of a regular polygon.